Welcome to the debate. Our focus today is digging into the core architectural choices behind the MauiPdfGenerator library. Now, this library, it's designed to bring that, fluent, familiar feel of .NET MAUI layout, things like stack layouts, grids, the whole layout cycle, into the, well, let's face it, often pretty rigid world of PDF document creation.
Right. And the central question we're grappling with here is, does this commitment to making it feel like MAUI actually give us a solid, predictable base for creating fixed documents? Or is the fundamental nature of PDF itself just so different that the familiarity ends up being, well, skin deep, maybe even masking complexity that's, frankly, sometimes frustrating?
Exactly. And I'll be arguing that leveraging these core MAUI concepts, the two-phase layout cycle, the Fluent API, actually does enhance predictability. It boosts the developer experience through that familiarity and, crucially, through some really important type safety tooling.
And I guess I'm coming at it from the other side. I think the fallacy here is trying to apply a model built for, dynamic screens that reflow onto a fixed canvas. A canvas with hard stops for pagination. Sure, the mimicry sounds nice, but I think it forces the developer to learn these kind of complex, non-intuitive exceptions that basically cancel out the whole promise of familiarity. The library's design, when you actually use it, seems to push you towards immediate structural workarounds that honestly undermine the MAUI paradigm itself.
Okay, I see why you might think that, but let me offer a different perspective, one that's really rooted in developer velocity and trust. The library, I believe, successfully lowers the barrier to entry precisely because it speaks the developer's language. It uses this Fluent API, right, that's designed as a really natural extension of the MAUI ecosystem's object tree. And crucially, the layout engine explicitly mimics the core MAUI mechanism, that two-phase layout cycle, the measure phase and the arrange phase.
Okay.
So for any developer who's used to building MAUI UIs, this sequence ensures a deeply predictable experience for how spatial constraints are calculated and then followed. You know exactly when an element figures out its size based on its content or, its parent's limits. And this predictability, it's supported by MAUI consistent contextual defaults, like children in a vertical stack layout. They just default to taking up the full available width. That minimizes boilerplate, aligns perfectly with how things already work in MAUI. But, and this is important, we can't overlook the tooling around it. The source generator workflow for managing fonts. This thing creates the type-safe PDF fonts class, offering really vital compile time safety against that super common nasty resource 002 font not found error. That provides a truly reliable, enterprise-grade workflow extension.
That's an interesting point about the developer ease, the fonts especially. But I'm sorry, I just don't buy that the familiarity really holds up once you get past, the absolute simplest single-page stuff. Where exactly does this MAUI familiarity survive the moment your content smacks into the unforgiving boundary of a fixed page, or when we actually need to distribute space proportionally? The attempt to force this MAUI-style layout onto fixed documents, it just inevitably breaks down when you hit core PDF needs, like managing horizontal space. And we have proof. It's right there in the documentation. For something as basic as distributing space horizontally, developers are explicitly warned a horizontal stack layout can overflow. Okay? And the correct solution? Forget the stack layout, you need to use a grid with star columns, grid unit type .star. That just flies in the face of what you'd expect a stack layout to do for basic arrangement, right? It signals a fundamental failure in the mimicry the moment structural layout actually matters. And what's more, the developer immediately has to learn and memorize this whole new concept. The difference between divisible elements, think of those like liquids splitting easily between lines, and atomic elements, which are more like solid bricks. They have to move entirely to the next page. This distinction, it's completely absent from fluid MAUI screen layout. It just adds immediate, critical complexity rather than reducing it.
Well, okay, I will concede that the jump from a fluid screen to a fixed document does require some specialized knowledge, especially around pagination. I grant you that. But the core mechanism of layout, I'd argue, remains predictable because of that two-phase cycle and the box model. The problem isn't really the layout system itself. The problem is that the canvas is finite.
Okay, let's focus on the utility of those stack layouts then, because they're supposed to be the cornerstone of this Maui familiarity, right? So if the documentation itself admits that the horizontal stack layout is, well, functionally unreliable for proportional space distribution, and it immediately pushes the developer towards using a grid with star columns, doesn't that make the stack layouts kind of superficial for any, sophisticated document design? I mean, look at the cookbook examples. Anything complex, whether it's distributing space horizontally or setting up headers and footers, forces the developer to get good with the grid.
I think that's maybe an unfair simplification. We are building professional documents here, not just whipping up a simple wireframe. The grid is indeed the most powerful layout, no question. And its prominence in the docs reflects that it's necessary for achieving that exact proportional distribution, which is absolutely critical in a fixed PDF format. The stack layouts, they still fulfill their purpose, managing simpler, single-direction sequences where you don't need explicit column math. The reliance on grid for that horizontal distribution isn't a failure of mimicry. I see it as a necessary optimization for the fixed nature of PDF rendering. Maui often relies on dynamic expansion if space opens up. PDF needs precise allocation using those star lengths. The architecture here is prioritizing functional correctness, getting the professional output right over maintaining perfect syntactical identity with Maui.
I just don't agree that it's simply prioritizing correctness. I think it highlights the cognitive leap required. The basic expectation that a horizontal stack layout would just distribute space somewhat evenly, or at least predictably, that's shattered. You're essentially teaching developers a tool, the stack layout, and then immediately saying, but wait, for the one thing you really need for professional layout, ignore that tool and use this other much more rigid one. But the problem runs deeper than just horizontal stuff. As I mentioned before, the vertical stack layout, this is probably the most common element for just sequencing content vertically, right? It carries this major limitation. It's defined as an atomic element. This means the default convenient wrapper element just fails. It fails to handle automatic pagination gracefully across pages.
Okay.
Let me just spell out the user pain point here, because it's significant. In Maui, I wrap related bits of content in a vertical stack layout. It's clean, it makes reusable components, logical spacing, all that good stuff. Now, when I take this very normal structural habit into the PDF generator, I've unknowingly created a structural time bomb. That VSL, it's a solid brick. If the content inside it happens to be taller than the space left on the current page, the entire block gets shoved to the next page, potentially leaving this huge, ugly blank space behind. And to avoid that highly visible layout -002 warning, element is taller than a page, a developer has to either, avoid wrapping content neatly and just dump elements directly onto the page's root layout, or resort to using a complex grid structure just to allow basic flow. This need to basically flatten your structural complexity, that's a critical functional divergence from Maui. It fundamentally undermines the whole promise of a familiar component-based vertical workflow.
That's a compelling critique of the consequence, certainly. But I would frame the architectural choice behind it differently. By adapting the two-phase layout cycle, the engine ensures that elements, like a paragraph for instance, are measured based on very precise constraints, like the available width, before they get positioned and arranged. This structural framework, combined with the predictable behavior of the box model, margin versus padding, ensures that when an element does fit, its spatial relationship to its neighbors is perfectly predictable, following Maui rules. The engine prioritizes the integrity of that measurement calculation first and foremost.
I see why you think that, but the predictability of measure range, it just gets steamrolled by the hard constraint of pagination. And that's precisely where expert knowledge becomes mandatory, not just nice to have. The predictability feels superficial because the instant content needs to flow onto the next page. The developer has to engage with the library's own internal rules about atomic versus divisible elements. Let's use that analogy again. A divisible element, like a paragraph, it's like liquid. It splits cleanly between lines when it hits the page bottom. Easy. But if a developer takes that nice, divisible paragraph and wraps it in an atomic container like a vertical stack layout again, a super common Maui component practice, they risk the entire structural block either failing to render at all or triggering that dangerous layout 002 warning if the content inside is just too long. This complexity, it isn't solved by knowing about measure arrange. It demands specific, expert knowledge of this library's pagination rules, not general Maui know-how. And this complexity is kind of confirmed by the existence of detailed diagnostic codes like layout 001, element overflows, and the common solution often cited, remove the wrapping vertical stack layout.
Okay.
And that is exactly the trade-off, isn't it? You're admitting the developer is forced to choose between the expected clean component structure from Maui and the practical necessity of making sure the page flow actually works. The library is effectively forcing Maui's structure to be functionally abandoned right at the point of implementation.
Well, I think that's a bit reductive. The library also offers sophisticated global configuration features, right, through dot configuration. These explicitly address the fixed nature of PDF documents. Developers can set document-wide defaults for things like page size. Page size, type, dot letter, or A4, and padding, or configure metadata like title and author. These features prove the framework does successfully balance Maui familiarity with necessary, robust, high-level PDF controls right out of the box. It clearly understands it's not just drawing to an infinite screen, it's compiling a structured document.
Sure, but those global configuration features, they're standard for pretty much any decent PDF generation library. That's table stakes. They don't really validate the layout philosophy itself. Let's maybe focus on the area we both seem to agree is a genuine strength, the source generator workflow for fonts. You're absolutely right. It is indispensable because it converts that font registration in MauiProgram.cs into type-safe access via the PDF fonts class. It eliminates that common, painful resource 002 runtime font error. That is excellent engineering, I'll give you that.
Exactly. And this dedication to type safety, to compile time validation, that is the highest form of predictability you can offer a developer. It extends Maui best practices like using strongly typed assets directly into PDF asset management. If the font system is rock solid and reliable, then the layout discussion can at least proceed from a stable foundation.
Right. But reliability in asset management is a totally distinct concern from the really complex challenges of spatial modeling and, crucially, layout failure. So I'm not really convinced by that line of reasoning connecting the two. Because type safety for fonts, great as it is, doesn't do anything to solve layout overflow, LAUT001, which the docs themselves cite as a primary failure point for the layout logic. The most common layout errors, the ones people actually run into, they get solved by structural changes specifically. Like we discussed, abandoning the intuitive stack layouts in favor of the specialized grid, not by improvements in API syntax for assets.
This disconnect for me, it shows that the architecture might be strong in these, ancillary features like asset management, but it's fundamentally compromised in its primary mission, bringing reliable, intuitive Maui layout semantics to PDF. The very elements that sort of define Maui layout, the stack layouts, are the first things a developer has to learn to treat with extreme caution.
Well, the caution is necessary because fundamentally PDF is not Maui. The engine provides the vertical stack layout because it is a known component. It's familiar. The fact that it's atomic, well, that's an architectural choice that likely benefits performance, and it certainly simplifies the measure phase calculation for that element. It forces the developer maybe to be more explicit about flow control, which arguably is a good thing when you're generating documents that absolutely must adhere to exact fixed dimensions.
Who are simply applying their existing functional Maui habits. You're leading them directly into these documented runtime failures.
Because I would argue it adheres to the logical separation of concerns inherited from the box model. The purpose of a stack layout is fundamentally to arrange its children sequentially and define a bounding box around them. When the engine measures that bounding box, it measures it as a single unit. It would introduce significant complexity, potentially, to try and break that logical grouping mid-page. complexity that could compromise the performance and the predictability of the two-phase cycle itself. So the trade-off was likely deliberate, simplified, predictable measurement for components at the cost of requiring explicit flow control for potentially large components.
So the architectural trade-off sacrifices developer intuition the Maui way for measurement performance? I mean, that seems like a pretty clear indictment of the whole philosophy, doesn't it?
Okay, wrapping up. I still maintain that the Maui PDF generator offers a highly capable bridge between the Maui ecosystem and PDF creation. By leveraging familiar concepts, the Fluent API, the box model, that foundational two-phase layout cycle, and then bolstering it with critical tools like the font source generator, it provides, I think, the most streamlined experience possible for developers making that transition from screen to document. And yes, while advanced layout that needs precise proportions will naturally guide developers towards the powerful fixed document optimized grid structure, which, let's be honest, is the correct tool for that specific job, the underlying foundation of familiarity remains sound for basic content structure and styling.
Well, the tension is definitely clear. That familiarity comes at a cost of functional reliability when you cross that boundary from the fluid world of screens to the fixed world of pages. And while tools like the source generator are, brilliant additions, developers have to be acutely aware of the crucial, documented differences. Specifically, the limitations of stack layouts for any kind of proportional distribution, and this critical atomic versus divisible element rules. To achieve truly professional, multi-page PDF output, without hitting those documented diagnostic errors, developers essentially have to learn to abandon the expected intuitive Maui structural patterns, especially nesting components deeply using VSLs, and instead favor PDF-specific grid mastery and very careful management of element atomicity.
And the material we've discussed clearly outlines the necessary considerations developers must make when trying to translate these fluid, screen-based concepts into the fixed document reality, underscoring the complexities involved.
Revealing a necessary, perhaps, but certainly complex trade-off between that conceptual familiarity developers want and the functional optimization required for a reliable PDF output. It's a trade-off every developer using this library will absolutely have to navigate.